The panel this afternoon is going to be on analytics for a transactive grid, and it's going to be moderated by Jill Anderson, Senior VP for Public Affairs and Business Development at NYPA. And to give us our last utility brief for the day, I'd like to invite to the stage Dan Zaweski, Manager for Planning and Evaluation at PSEG Long Island.
Thank you. Thank you for the opportunity to address you this afternoon. We're probably a little bit different than many of the IOUs who mentioned this before. PSEG Long Island is a subsidiary of Public Service Enterprise Group, $11 billion corporation. PSEG Long Island itself is underneath a 12-year contract to operate the Long Island Power Authority's transmission and distribution grid. That grid delivers electricity to approximately 1.1 million customers out of that in Nassau and Suffolk counties, and that portion of the Queens County called the Rockaways. Customer split is about 1 million residential, about 100,000 commercial customers, and annual revenues is split just about 50-50. Our mission statement is to be a leading electric company dedicated to exceptional customer service, best-in-class reliability, best-in-class storm response, and strong community involvement. As part of that, when PSEG signed the contract, they made a commitment to take customer satisfaction from the absolute lowest in the country to the top quartile in 5 years. So in addition to that challenge in and of itself, some of the other challenges we're looking at are relatively similar to what you've heard from some of the other utilities. Forecasted load growth going forward is very low. However, despite that, there's certain portions of the grid that are growing on us, and as they become constrained, traditional utility construction is being opposed more and more and more in our neck of the woods. Projects are met with either a demand for undergrounding or not to be conducted at all. And from a reliability standpoint, it starts to really present certain challenges. In addition to that, we are quite fortunate. We have a very robust PV program on Long Island. We have well over 20,000 net metered customers, and that combined with feed-in tariffs that have been offered in the past couple of years has resulted in us starting to bump the limits for interconnection in certain circuits, certain subfeeders, and certain substations. So how we're going to address that going forward is definitely a challenge for us. In addition to that, we also have a well past prime DLC program. I think we are probably the sole reason there are still paging capabilities left on Long Island. And last but not least, due to prior contracting practices that happened with the Long Island Power Authority through the years, we are now very long on capacity. And what that means for us is, as we go forward and do cost-benefit analysis, avoided T&D costs are going to become more and more of a prime driver for making benefits actually work. On the demo side, we've yet to file a demonstration project. We should be having one filed shortly. That demonstration project is going to be an on-bill financing project. Underneath that, this project is to demonstrate a shift in approach used to fund clean energy. In a planned partnering with the New York Green Bank, we will have a loan program aimed at spurring private capital investment in cost-effective, clean, distributed energy resources in concert with the overall REV strategy. It'll shift some of the financial burden from all ratepayers to private equity investments, and we think this will help sustain the existing industry on Long Island beyond the expiration of the federal tax credits and beyond the expiration or the conclusion of the New York Sun Initiative. So kind of leading into the panel discussion, we have a numerous avenues where we're seeking DER solutions. We have an RFP that's out there for the South Fork of Long Island looking for capacity relief. We have planned RFPs that are going out for a number of capital projects looking for alternative solutions. Like many of the other utilities, we'll be filing dynamic load management tariffs. And the question becomes, if we're successful and if we have a high diversity of suppliers, how do we handle the challenges of dispatching, scheduling, monitoring, and settling all of these transactions? And that we're looking forward to hearing from the panel from. So thank you.
Thanks for that perfect introduction. I'm Jill Anderson with the New York Power Authority, and on the stage with me I have Karen Butterfield from STEM, Lawrence Jones from Edison Electric Institute, Emily Wheeler from Smarter Grid Solutions, and Ron Ambrosio from IBM. So to set the stage for what we're going to be talking about, I like to go back to a quote I heard from Eric Schmidt a couple of years ago when he was the CEO of Google. And he said that we at that time were generating more information every 2 days than we had previously generated if you added up everything from the dawn of civilization to the year of 2003. And it sounds tremendous, right? But that was, I think he said it maybe in 2010. And if you go now to try to get an updated amount, okay, how much information are we generating now every day? No one's even looking at it in days. We're talking about how much information we're generating every minute. And it's a tremendous amount of information, and that certainly is very applicable to the energy industry. I mean, just thinking about metering as one example, when you take a meter that you would normally read once a month and turn it into a smart meter that has the capability of giving you data maybe every 15 minutes, you know, that's a 3,000-fold increase in the amount of information that the utility or the meter reader is collecting. And so what the transactive grid is talking about, and what we're going to talk about on this panel, is how do you take all of this data and actually turn it into useful information that's enabling a cleaner, a more efficient, a more affordable grid. And certainly we've heard already, I think every panel before us, someone has talked about data, someone has talked about analytics and how critical it is. And also people are recognizing that there's a lot of challenges in this area. The data we're collecting now is imperfect, the access is difficult, and there are obstacles. So why I think we all should be excited about the panel today is because we're going to hear about how these experts are addressing those obstacles, how they're already making progress to making that transactive grid a reality, and taking all of that data that we're all generating every minute, even in this room, and turning it into useful information. And so with that, I just want to start right off. And the first question, I'm going to ask Emily to talk a little bit about a REV demo. I think it's perfect for this setting, and her company is working already with Iberdrola on doing a demonstration in the transactive grid.
Yeah, great. Thank you, Jill. So Smarter Grid Solutions is a partner to Iberdrola for the Flexible Interconnection Capacity REV demonstration project. And what we recognize is that there are a lot of challenges with interconnections for solar and wind developers. There are both technical issues and there are both commercial issues as well. And so we provide solutions that help overcome some of these barriers and increase the amount of generation that can connect to the existing grid while maintaining a safe network. And so what I mean by this is if you're a PV developer and right now you want a connection, you may submit an application and find out that you have to pay for a very expensive reinforcement cost. And that stops the project from going forward. And so Iberdrola saw this happening with over 50% of their projects that they saw come in. And really that's a problem that we're trying to tackle in this REV demonstration project. And so what projects that would normally require cost prohibitive upgrades, we can get them onto the system if we just manage them a little bit differently. And we've proven that this can work. By the end of the year, we'll have over 250 megawatts under control in the UK utilizing our technology. And Iberdrola, they're the first ones tackling, using this technology and tackling these problems here in New York. And we think it's really exciting, and we're excited to use this distribution technology to be able to do this. But really, it isn't about just the one or two PV vendors that participate in this REV demonstration project. It's about how you plan and operate the distribution system to benefit all customers. Reducing the amount of reinforcements that are required and getting more out of the existing system. Doing it in a way that's fair and transparent and creates market opportunities and creates new access and new revenues for Iberdrola as well.
Thanks. So if we continue the demonstration theme, I want to ask Ron to talk for a minute about a project he's been involved in the Pacific Northwest. I think there were 5 different states, and that demonstration recently yielded some results.
Yeah, so that was the Pacific Northwest Smart Grid Demonstration Project. That was the largest of the ARRA-funded smart grid demonstrations. We had 11 utilities and Bonneville Power from BPA's service territory. There were about 60,000 customers, either directly or indirectly involved, about 90,000 responsive energy assets that were being managed under the project. Examples such as demand response, substation, battery installations, EV charging, number of other things, a lot of variety across each of the 11 sub-utility projects. What we did on the project was to implement a distributed transactive energy management system using an Internet of Things software agent framework developed in my lab up in Westchester County at IBM Research, and it's based on an ISO IEC international standard. We created distribution level transactive control nodes or software agents that managed individual assets or systems of assets. And we also developed transmission level transactive control nodes to manage the coordination of those assets for the benefit of the entire system. The project really also built off the success of an earlier project that we were involved with Bonneville Power and Pacific Northwest National Lab called the Olympic Peninsula Demo. So just briefly, to try and clarify what transactive energy management is it involves the use of economic value signals that represent the value of achieving either operational or business objectives or the cost of addressing constraints. I'm using the term economic value rather than price because on the demonstration project, we were basically reflecting the cost of delivery of energy as these signals flowed through the system. Price may or may not come into play at the boundary with over the customer meter, for example. That's one type of incentive mechanism, but you could use any number of different incentive mechanisms, and you can drive it with this kind of economic signal. We've been hearing all day about the importance of value identification along the electricity delivery chain, and transactive energy is really a mechanism that's designed to try and represent value and to try and expose it in a way that it can be used to build new kinds of solutions and potentially support new business models. And that might take place in a market construct, or it might be used in a more distributed agent-based construct as we implemented on the Pacific Northwest demonstration. It all doesn't run in the data center. Ultimately, though, I believe what will happen is that we'll end up with more of a hybrid approach where we'll have highly distributed agents managing individual assets and subsystems and interfaces with energy gateways and things like that, but we'll also have aggregation points that are market-based, perhaps at the microgrid level, the nanogrid level, the DSP level. So I think we'll have a combination of both market and non-market mechanisms, but you shouldn't associate transactive energy simply with markets.
Okay. So now I'd like to ask Lawrence, because we talk about transactive grid here, and we start out talking about 2 different demonstration projects, but utilities have been managing some form of transactions on the grid since its inception. So what are we really talking about that's different now than what utilities have been doing all along?
I think, first of all, thanks, Jill, for the question. And again, thanks to Mika and others for the invitation. I think what is different now, and you're right, we've been dealing with transactions on the power grid from its inception, right? And I think one of the things people don't realize is that when we say transactive energy, just to not confuse people, we're not talking about a new form of energy being created, right? Because I've gotten that question before. Well, we've got transactive energy. What is that compared to the other kind of energy, right? Reactive energy. So that's something to clarify. But I think what's interesting here is that we've seen over time time, internationally as well, we've seen this proliferation of control systems across the grid. And as we spread out more control systems across the grid for operating the power system, we're seeing today, compared to what we saw in the past, an increase in the level of interactions between different control systems, right? And so what Ron talked about in terms of the value signals, basically what that is if you go back to the sort of a grid before, was just take something like voltage control, right? There's a transaction that's going on, except that transaction is not visible to the utility operator unless there's a signal there. It's not visible to the consumers. Now, what transactive energy does, it allows you to capture all of these interactions between everything on the grid that moves. So just imagine, as we sit here today, every single device on the grid is moving to keep the lights on. The issue is some of them are moving more than others. Some actually never move, right? And we've aggregated the behavior of the grid at a macro level. So we'll be able to see, measure everything at the macro level and say, we take law of averages and we have average information about different signals. Well, transactive energy, now you have all of this ability to capture operational information for every device, everything that is moving. We can now see, at least, I won't say in theory, but we're getting to the place where we'll be able to see the contribution from every device, every transaction, every motion on the system adds some value. The problem is, and we've seen this in Europe, we're seeing in other countries where they're trying to explore this notion of transactive energy, is how do you monetize or sort of put a value on the action of every single device that moves? Now, that creates a lot of information, because if you imagine a control signal, for example, at the generator control signal that moves up and down to keep the frequency up, if you monitor every movement up and down, you can actually ascribe the injection of megawatt contribution from that movement up and down from that device, right? Now imagine doing that for every single control system or control signal on the grid. That creates lots of information. The challenge for Ron and others is, how do you then tell the utility that every device that moves added this little percent of dollar or whatever to your overall costs, right? And that's what I think a lot of people around the world are beginning to look at, is because from an investment standpoint, if you can actually evaluate the control signals of every moving device on the system, well, that's a lot of good information you can use when you do your investment calculation. The other thing that's different today compared to the past is that with transactive controls, you can now actually look at the life expectancy, if you may, of a device much better today than you could in the past. Because if you have a bushing, for example, or you have a device on the substation that's moving up and down, typically we don't look at that device and every movement, we look at it at the substation, right? And we sort of will average everything up at the voltage level. But if you have a tap changer, for example, that's moving a lot and adding value to the system, well, that tap changer should be paid for moving up and down, right? Today, we don't add value to that because it's just complicated in the past. Today, we can do it because now we can measure every single action on the grid. And if you put that in the same context of the rev year, which is what the whole discussion is about, you would want to be measuring every motion, sensing activity on the distribution system, transmission system, and the entire value chain. So everything that moves has value. The problem is, how do you calculate that value? And that's what transactive energy is trying to do.
So let's build on that and have Karen talk for a minute about what you're doing with Southern California Edison, right, with the local capacity program. And there's a case where you have a value for what you're putting into the grid. How is this a transition from a traditional utility program to the transactive grid concepts we're talking about here?
Sure. Well, first of all, the bid at Southern California Edison was an all-source bid. So they had a problem. They identified a problem at SoCal Edison that they wanted to solve, and it was capacity, local capacity. And they went out and said, what do you have? They asked the marketplace, what do you have? And all kinds of different solutions came in, everything from gas turbines to energy efficiency to solar and storage, which is what STEM was awarded. We were awarded 85 megawatts of storage within that geographic area where the San Onofre nuclear generating station was, in the past, had been supplying electricity. And STEM solution is is a behind-the-meter battery solution with software and analytics. So we take a battery and we install it in a commercial customer facility on the customer side of the meter. And then we take a meter and a revenue grade meter, a computer, and a wireless connection to the cloud, and we charge and discharge that battery for the benefit, in this case, the benefit of the grid. You heard, if you were in the morning session, you heard behind the meter storage can also be beneficial to the individual customer by charging and discharging on that econometric model with the tariff. So you have a demand charge, or you have, in theory, you could have arbitrage, and you're charging and discharging that battery for the customer's benefit. In the case of Southern California Edison, we're going to do both. We're going to co-optimize the charging and discharging. So when Southern California Edison calls us, we can, just like a demand response program, we can deliver 85 megawatts to the grid. And our view of this is that, over time, we will get to transactive grids. We are starting to see these pilots, and especially in New York, we're very interested in 3 or 4 of the programs that are here. But what the Southern California Edison program is, it's a market proxy. They've set the price by going out to bid for a megawatt, a capacity price on a competitive basis. And so it's this evolution of these utility programs. The last thing I'll say is the data. And STEM solution collects real-time 1-second data from the meter that we install at the customer's premise, and 1-second real-time data from the battery system. And that's how we make the decision to charge or discharge. And that data is very, very valuable to us. And it's valuable, some of it's ephemeral. I mean, we only need to know the temperature of that battery at that very moment, but we don't need to store it, per se, for a year or something like that. What we do need is data that we can settle with the utility when the services are being paid for. So that's a little bit of a summary of the program in SoCal.
So I'll ask you, or whoever else wants to go a little deeper talking about meters. Because you talk about transactive grid, and a lot of times you hear about the need for smart meter penetration in order for this to come to its, the dream end state. But is that really true? Do all the panelists agree how critical are smart meters? And if so, who should be paying for them? Should it be all the ratepayers? Or if there are third parties that are going to be transacting with this information, is there a willingness for other people to do meter deployment?
Well, our view of metering is that we need high-definition metering at the site, and so we cannot rely upon the utility meter, and we are going to pay for that meter in the entire service. So we provide the service, we include the costs, and we pick up the 1-second real-time data.
So I actually don't agree that it's an absolute threshold technology. It really depends on what the use case is that you're implementing, especially in a transactive environment. You may need accurate load information or some of the other information that you get out of an AMI system, but there are a lot of use cases that don't require it, and so it's important, but I don't consider it a threshold that we can't get started until we have the meters installed.
In the demonstration project you did in the Northwest, was that part? What role did smart meters play?
It was a mix. Some of the utility sub-projects installed smart meters, in many cases to enable communication for DER management and things like that. But not all of the sub-projects involved metering. And again, it really depended on what was the particular function that was trying to be implemented in that case. Sometimes you need the meter data, sometimes you don't need that level of revenue grade meter information. Sometimes you can get by with, with estimates and modeling and things like that.
Just make a point. So, the question as it's asked kind of brings transactive energy or transactive grid back to solely the distribution system, right?
Right.
I see transactions occurring from generation all the way down to consumption, right? And so you need different types of sensors along the entire value chain or the entire value chain of the grid. And so, like Ron said, I think you were into this, depending on the use case, you may or may not need, in this case, an AMR or a smart meter for that. But I think we need to be clear that as we want more things from the grid, and by grid I mean from generation all the way down, whether it's renewables, whether it's transmission systems, whether it's high voltage direct current, or whether it's flexible AC systems on the transmission side, as well as much as we want to get more flexibility from the grid. Information systems and sensors allow us to do it, and so we shouldn't just focus Transactive Energy solely on having smart meters for the distribution side, but we should look at the totality of us wanting a transactive grid that sort of allows us to monetize transactions across the entire value chain, and then we decide what kind of a sensor we want on the generation side or on the distribution side.
Yeah, and to follow on that, even within the distribution system, tying to meters kind of implies that what you're most worried about is load management.
Yeah.
And we had, some parts of the demonstration project in the Northwest were doing volt-var control and voltage stability and things like that. They really, they needed sensor information from within the distribution system. They didn't necessarily need it, information from the end meters. So really, it depends on what you're doing in any particular case.
So talking about that, the utilities then have a lot of data already, whether they've done a smart metering program or not, right? If you talk about tap changers, they know the tap positions. So maybe Emily could talk for a minute about this concept of how utilities are already awash in data. What's the roadmap for helping unlock the value of that data in this transactive grid environment?
Yeah, I think we're already seeing some good examples, for instance, with BQDM, just providing some information around how utilities are planning can help developers in those areas know, how what they're going to build in that area will affect the grid and how they can derive more value from it. So I think that's one example. I also, looking at other countries too for where they've been successful. In the UK, there's something called the long-term development statement that's published by their distribution utilities. And basically what it is you can look at a specific point within their network and see at a given date what the capacity is in that, at that point. So the idea would be, Jill, if you have a friend that lives in upstate New York and who wants to deploy some solar panels, they can go and look at the study and see which substation they would connect to and what the capacity was May 15th of this year, and get an idea. Okay, there's 10 megawatts of capacity on that substation. Yes, I could probably deploy there, and that doesn't exist yet in New York. And for developers, that means they can derive some economic value before they even submit their application. But I think that's something that could be done. You can look at California, some of the heat maps that are already available there, and that's all helpful. But we think there's an opportunity for utilities to look at how they could help customers take the data either through, and use that data either through innovative technologies like ours, or hooking up with a storage solution. There could be bilateral arrangements that are made, and it would require new analysis or tools that could be done by the utilities or by third-party vendors, and this, of course, would all require utility data.
So you opened the door to talk about what's going on internationally. I know Lawrence is doing a lot of international work now. So who do you think is making strides in this area, or where are there lessons that we could apply to New York?
So let me talk about who's making strides I won't talk about who's ahead or who's behind, because I'm going to get in trouble. But what I would say most seriously is that I think if you look at the European countries, there are a lot of smart grid demonstration projects in Europe. When those projects started, most of them were sort of a deployment of technology. You had the synchrophaser type projects, you had projects around distribution system optimization and what have you. What we've seen over the last couple of years at least, for example, there's a project funded by the European Union called iTesla. That project is actually looking at the use of data from transmission all the way down to distribution. And there's another interesting project in Europe where, this is in Denmark, where they're actually integrating operational data from real-time system operation and asset data from asset optimization, and they're bringing it together. Because what they're beginning to realize is there's a lot of value in bringing asset operational data and grid operational data together so as to really optimize how you use your assets. That's one example. The other thing in the issue of how utilities are doing, if you look at what is happening with regards to renewable integration, again, coming back to the Danes, one of the things they did very well was to actually capture as much data about the operation of wind farms. And they then went to look at the correlation between wind farm performance as well as the system performance to be able to better dispatch how the system would work. So I think more and more utilities around the world are beginning to harness the data they've captured. Where I think we need to all sort of spend more time on is to really define what kind of knowledge we want to extract or insights we would like to extract from all of the data we've gathered. We've been collecting SCADA data for decades, right? And I remember I was in Asia not too long ago, and this gentleman said, well, Orange, we have all this data. Is about a very large country in Asia. They have all this data we've been collecting. What should we do with it? I said, what do you mean? Well, they keep telling us to put even more sensors to collect even more data. So the data has been collected, but I think we need to now, we as an industry, need to spend more time seeing how can we use correlation analysis, big data analysis to really extract value from that. Because the problem is, the last thing I'll make here is that some of the data, there's no sort of a closed form equation to relate a wind speed to, for example, what's going to happen on a transmission system, right? So you have to use correlation analysis to look for not exact answers, but it will give you some indication as to maybe if I move this parameter, it may have an impact on this. That kind of a big data analysis based on correlation analysis is something I think our industry needs to spend more time doing.
Ron?
Yes, follow on to your comments there. In our lab, we really think that the key lies in uncertainty.
Yes.
And in the quantification and management of uncertainty of all sources, both in operations and in business processes in the utility system. So, if we can start to quantify uncertainty, we're really starting to quantify risk. And if we can manage it, we're starting to manage risk. But by quantifying uncertainty, we can begin to understand the value that's inherent in managing that uncertainty. So that gets us back to how do we start to explore exposing and understanding the value of being able to put these kinds of systems in. DER management, transactive energy, a lot of the other things we've talked about today are tools that'll help us manage uncertainty. But quantification of uncertainty is going to require modeling, simulation, and analytics, both big data and what we call small data. So our transactive agents on the Pacific Northwest demonstration were small embedded agents running analytics algorithms, small scale models, things like that, in addition to having back-end agents that were leaning more heavily on big data type real-time analysis. So any roadmap that we want to put in place is really going to have to include a platform architecture that can support those kinds of capabilities as well.
So talking about roadmaps, I think we'd probably all agree that any additional information collection or information sharing that we're doing on the energy grid is going to have a lot of cyber risk. So maybe we could spend a minute talking about what some of those concerns are, how they're being addressed, or is it an obstacle? But how are we considering, or how should we be considering the cyber concerns in this transactive grid environment?
I don't think we need to sort of try and create a whole new framework just because of transactive energy, right? I think we can build upon what already exists. I mean, there's work being done today within NERC. I know the White House is coming with some declaration around cybersecurity. There's work being done by the industry. I think if we jump to starting to want to create a whole new set of a sort of a requirements just because of transactive grid, I think we'll make a mistake. I think we should build upon it. And again, like we've done in the NIST, the NIST world, where we've looked at the smart grid interoperability activities. Let's identify where there are gaps and see where we need to close those gaps. The bigger issue, I think, will be how do we get everyone to realize that utilities wanting information doesn't have to always be a bad thing, because at the end of the day we still give information to people who we don't know anyway, right? And so I think utilities need information sometimes to really operate the system, and I think it's incumbent upon us to explain to those who have this fear that utilities want my private information. I just as an aside here, I said to someone once, what is better? To enter your information into an application and to buy something on the internet that keeps sending you, more information about things to buy, and you do it without any problem. Mm-hmm. But then something that would actually help keep your lights on, all of a sudden you have an issue with it. So I think we need to be very careful with it. Overemphasis on cyber because of transactive energy.
Yeah, I agree. And on the Northwest demonstration, one of the things we did, and this is an example of, we've got a lot of techniques that already exist in other domains as well. We use certificate-based authentication in the agent framework that we were using, so that we could trust that the information packets we were receiving originated with the agent that we believed it originated from. That doesn't necessarily mean that that system hadn't been compromised, and that's a totally different issue. Yeah. But I think as we get into these large-scale, loosely coupled systems of systems that we're talking about with the smart grid, and this gets back to some of the real-time analytics, simulation, and modeling, I think there's a lot of work that needs to be done in building sort of supporting systems that help us detect emergent phenomena. Some of that emergent phenomena, some of that emergent behavior may just be system instability, and we need to know about that too, but some of it may actually be malicious attacks. So I think there are, we have to always design for the fact that we can't build a completely secure system. We just can't. So we have to build a resilient system. And part of that is building the technologies that will help us to spot when there's a problem emerging.
I just wanted to agree with Lawrence and flip it around a little bit too. A lot of the data that we're talking about providing to utilities for the grid, the customer needs this data too, and commercial customers utilize this data. And this is a like 20/20 vision for customers all of a sudden to see their building operating in 1 second real-time basis. And those anomalies on the grid, those can be seen at a customer building as well. Just very simply, a customer could look at their building on a 1 second or 10-second basis, and all of a sudden can pick up that a motor is about to fail, and it's cycling on and off and on and off. And so the notion that we're going to give customers access to more data will make those customers better participants on the grid as well.
So maybe you could take it to the next step. So we talk about all the value that these transactions, this information could provide for the utility. How does it eventually translate into lower customer bills? Does it?
Sure, I think it does. And we talk about the battery and how many values there are to a battery. We've talked a little bit about the behind-the-meter demand charge reduction, potential for arbitrage in price, the potential for supplying capacity to the grid and to the utility for purchase. But there are probably 15 more opportunities for a customer to benefit and for the grid to benefit from this little storage device and software that's installed at the site. And we see customers all the time who see something going on with their building and then find a way through the software to double their savings from what they were saving from the battery. And finally, in California, we just recently bid into the independent system operator, the Cal ISO market. We had been bidding in a day in advance, a day ahead bid. We just started bidding in five minutes ahead. And essentially what we're doing is taking the fleet of batteries, looking at the state of charge of the entire fleet by adding or aggregating all of the individual batteries. And then our team has developed the algorithms to bid 5 minutes ahead into the grid. And that's a whole new source of revenue that we didn't even foresee when the company was founded 6 or 7 years ago. So these are new sources of revenue that are just coming up, and we're taking advantage of them.
The comment I'll make on that is so, the transactions across the grid, some of the benefits may end up being sort of at the macro level, right? And they may not necessarily sort of be something that the customer may see immediately, but they may have system-wide benefit. And I think we shouldn't forget that some of the transactions along the grid, across the grid, will bring about system-wide benefits that may not be obvious to sort of the end-use customer. I'll just make a very interesting note here. So my wife and I just moved to a much bigger house because of twins. So if I fall asleep,
5-week-old twins.
5-week-old twins, right? And what is interesting is that, so my wife said we need to get another TV, we need to get all this other stuff. So we went to Verizon and we sort of beefed up the house with all this new technology, right? And as I'm looking at my electricity bill, it's actually still low. But my cell phone bill, it's just skyrocketing. And so when you say the value, I think oftentimes we see electricity as being so expensive. But in fact, it's actually many times way, way cheaper than everything else we have in the home, right? And so just a point here that if we can have more transactions to lower my telephone bill, I'll probably be happier than my electricity bill at this point.
I think the question also gets right back to understanding how does each piece from the different parties involved contribute to the overall value, avoided costs, whatever. And it's so important in not only understanding those contributions, but in having a mechanism like Transactive Energy that allows you to start building a system that can carry and convey that information so that you can now take the next step of looking at new business models that may lower the bill because the customer is providing some value back into the system based on their investment, or the third party is providing value back in. The Gridwise Architecture Council is having a workshop next week at ERCOT down in Texas on transactive energy valuation. It's actually a continuation of an earlier workshop and working on exactly these kinds of questions.
And just one thing to add to that, so typically transactive energy is broken up into energy and also the transport of energy. And I think, one thing that's been looked at too is, maybe if you're a residential block and you need a high level of reliability, but maybe if you're a solar developer, you don't need that same level of reliability. And by not having that additional system-wide investment in that reinforcement, that could end up being system-wide savings and customer savings.
So I think we have time for one more, and I want to start with something a panelist said earlier today about how accessing data is critical, and that's still very difficult. And I think he gave a couple of examples about how he even has to use a fax machine to get data from some companies. So maybe each of you could talk a little bit about data access and where you think we are or what you think we need to do to make that easier for everyone who wants to participate.
All right, so I'll start, since everybody's turning their head to me for some reason. I think part of it is the importance of continuing to not only develop information model standards, but to adopt them, because that's an impediment. If the information is in so many different formats and some of it's proprietary and some of it's not, that just makes the problem that much harder. So that's part of that. I think how we architect the sorts of platforms that we're building these future systems on needs to include a much more open shared data storage paradigm where different applications are working off the same centralized information models, again, with common standards. I think once we start to do that, we'll be able to then look at, okay, should we place all of that data in a secure cloud environment that more and more entities can access? access with the right kinds of security controls? Does some of it have to be resident on premises at the utility? Maybe there's regulatory rules that don't allow data to move across a state boundary or a country boundary. I mean, we face that today, and it's one of the things that is holding up, for example, cloud-type implementations that might help solve some of these data sharing and data access issues otherwise.
Emily?
Yeah, I mean, I think just looking at other states and other countries for models that already currently exist and taking the steps that work for the data that's available now, I think that looking at the heat maps that are available in California, I think even that step alone can go a long way in helping customers make decisions about where to deploy technology.
I would say that there are two things to this issue of data access. One is, I think, educating the customers, but by customers I mean everyone, the broad definition of customers, right? Because oftentimes when people say customer access, I don't think my mother needs access to all her information, but somebody might use her as an argument to want data, right? So we need to be specific who actually wants the data. But I think the other thing that's more interesting, and we've seen this in Europe, is that the responsibility of protecting the data has to also go with the access to the data, right? And that becomes very interesting because from the customer's perspective, the utility owns the data, right? Or holds the data, preserves the data. When that utility gives the data then to another third party, well, is the customer knowledgeable now that their data, if it becomes compromised, is no longer the utility, it's actually a third party? That handshaking from one party who owns the data to another, it's extremely difficult to resolve because everybody wants the data, but nobody wants to be liable if the data gets breached. And the liability is always put back on the source, not on the other third-party folks. So I think that's something that the policymakers need to grapple with very carefully.
And Karen, you get the last word.
I think two things, the same as Lawrence. Two things. One is standards, and the other is permissions. And so we deal with standards for data all the time when we're transmitting data or receiving data, 15-minute data from the utility to do the analysis, and then permissions. So when the customer says, yes, you can have the 15-minute data from the utility, we want the data. We don't want to wait 3 weeks or a month or something like that. And those two problems need to be solved so that we can have the third party and the utility, both enjoying access.
Great. So I'd like to thank the panel. I think this was a great summary of all the issues that were brought up today.